and we said, oh, I wish this would go away because there is nothing I can do to x. I cannot erase it, of course. I have to use a substitution. So I said, what if I denote x squared minus 6 by any letter, which is basically a function, but any letter. So we chose h. Fine. So then if the substitution is x squared minus 6, this piece must change into h to the 7th power. But now I have to analyze the rest. And if the integral has dx, when I change it to h, it must have dh. Otherwise, the integral doesn't exist. So once I determine or I choose this to be the function in question, I have to find its differential. So then dh is 2x, and x is in the problem, dx. I'm happy because I have the x and I have the dx. Who cares about the number? A number I can make up anytime. I write 2 over 2. I connect 2 to x to dh, to dx and to dh, and the 1/2 goes in front. I couldn't care less. So now you can say, show me that when you differentiate this, you get that function. Of course. Of course. It will take a blink. So when I differentiate this, I have 1 over 16. So this is my check. 1 over 16, 8 comes in front. Subtract 1 from the power and multiply by the inner function prime. And 2 with 8 and 16 go away. So the function is back to x squared minus 6 to the 7th power times x. And that's exactly what we started with. X squared minus 6 to the 7th times x. For the indefinite integrals, we can always check. Would you feel like choosing the next problem, or I will? Okay, you will choose the next one. So 15 on the same page. The integral from x to the 4th e to x to the 5th dx. So what bothered me here was this function inside of this function. That bothered me because it was a complicated situation inside of power 7, inner, outer. I know that this is not a scientific way, but it's an easy way to think about it. What bothers you here? And that will be our starting point. Any idea what bothers us here? Again, it's a product. X to the 4th times e to a power. What will you say bothers you here? Look at the product and say, I think this or that.
Ex to the 5th.
Absolutely. Thank you. This bothers me because it's the power of another function. Instead of e to the x, I have e to this function. That's my starting point, in the hope that du is in the problem or easy makeable. What is du for this function?
X to the 4th.
Remember, this is not the derivative.
Plus times dx.
Times dx. So please remember, for du, if the function has x, then you have to have dx. Okay, do we have 5x to the 4th dx in the problem? Almost. This I can always make up. Multiply by 5 and divide by 5. This is 1. But I have what I need. I have the 5. Yes?
Where do you get the 1/5 from, real fast?
So I cannot, so 2 over 2. I cannot simply multiply by 2 and pretend that is the same function. It will not be. But if I multiply by 2 and divide by 2, then I guarantee you this is the same function because 2 over 2 is 1. So if I multiply by 5, I have to divide by 5 because only 5 over 5 is 1.
Okay.
But now I have what I need. I have the 5, I have x to the 4th, and I have dx. All this, don't cross it out. I'm making a point. 1, 2, 3, what are those? One, two, three. What are those? Replaced by.
du.
Exactly. 5x to the 4th dx. 5x to the 4th dx, they're du. Can anyone tell us what will this become?
E to the u power.
That's it. 1/5 e to u plus a constant c. It's done. 1/5 e, I have to plug it in now, x to the 5th plus a constant c. So one more time, the substitution helped us. It simplified all this into something that we can handle very easily. I didn't know what all that meant, but after I applied the substitution, I replaced the du, these three quantities by du, and this quantity by e to u. The rest was clear.
Can we do another one of those, please?
Of course. Of course. Let's say 17. And we have the integral from t squared e to negative t to the 3rd dt. What do you think we will use as a substitution?
Negative t to the 3rd.
Of course, because dy is, and after that we have to determine dy. What do we get?
2t dt.
Careful.
Negative 3t squared times dt.
Brilliant. And now let's see what we have. I have dt. Awesome. I have t squared. Awesome. I don't have negative 3. Who cares? Negative 3 over negative 3, which is 1. Now I have all three pieces. Negative 1/3 stays outside. This and this and this will make up what?
E to the y dy.
Yes, yes. E to y already, yes. I was looking for just dy, of course. So this is indeed e to y. And 1, 2, 3, 1, 2, 3 are in dy. Excellent. Now this is again a piece of cake, negative 1/3, e to y plus a constant c. Once you understand it, you cannot see anything else. So e to y plus a constant c, negative 1/3, e, I have to go back to this, negative t cubed plus a constant c. Excellent. Okay.
Could you move page 7 up a bit and then copy the whole thing?
Yes. Is this better?
Yes.
I would like to look at the definite integral, and then we'll go back to other examples. But I would like to illustrate now the definite integral. Moving on. Is this okay? Yes? Can I move
Yes.
it? Okay, perfect. Good. So let's look at 45. So the integral from 0 to 1 from 3x squared e to x cubed dx. So this is a definite integral because it has limits of integration. Okay. Let u be, you can use any letter. You can use anything but x. You can use a, b, c, t, u, y, anything you want, anything that pleases you is fine. As long as you are careful and you do not have both variables in any of the integrals. When you move from x, you have to completely move from x to u. Okay. Can anyone give us an idea?
X to the third.
Of course. We
And
already.
Can I do du?
Please, please.
3x squared dx.
Perfect. Do I have 3x squared dx in the problem? Yes, I don't even have to make any adjustments. Do not copy the limits of integration, please. So let's continue. Do not copy the limits of integration yet. So please tell me what to write. Anyone would like to try?
E to u du.
Perfect, awesome. E to u du. Now we need limits of integration. Careful. When the limit of for x, the lower limit for x is 0, what will be the lower limit for u? When x is 0, how much is u?
0.
Perfect. When x is 1, how much is u?
1.
By chance, it happened that the same limits are here that were for x are the same for u. It's very unlikely that that will ever happen. So now this is e to u from 0 to 1. Careful, this is not a polynomial. When you plug in 0, you will not get 0. So when I plug in 1 minus when I plug in 0. Okay, so let's take a look at 51. The integral from 1 to 3, from 2x plus 3, everything divided by x squared plus 3x dx. Well, this looks kind of messy. So the same idea applies here. When I look at the numerator, there is nothing I can do to the numerator. What really bothers me is the denominator. Because if I have one term, it's one thing. But if I have a term plus another term, this is more difficult. This I know how to handle. But this one is a little bit more difficult. I have a sum in the denominator of a fraction. No one can simplify that. So I will say let u be x squared plus 3x. only if du is in the problem or easy to make up. What do I mean by easy to make up? Just address a little number. I cannot make up x or x squared, who knows, depending on the problem, but a 5 or a 1/2, I can always make up. So what is the du if I choose u to be this denominator, because this is what really bothers me, terms in denominators. So what will be the du of this function?
2x plus 3 du.
2x plus 3, because it's x, excellent, dx. Right? The function is in x, I have to have x here. If I have x here, I have to have dx here. Is this okay?
Yes.
Excellent.
Sorry. Yes.
No problem. Ah, yes, I have it. It's right here. Good. So now let's see how we change this. Do not copy the limits of integration. The limits of integration for x most probably will not be the same with the limits of integration for du. So that's du. 1 over, what do I have in the denominator?
U.
Very good. Careful now, careful. When the lower limit for x is 1, what will be the lower limit for u?
4.
Excellent. When the upper limit for x is 3, what will be the upper limit, corresponding upper limit for u?
18.
Very good, awesome. You understand that here u is, x is clearly between 1 and 3, but u is a function. When I plug in 1 here, I get 4. When I plug in 3 here, I get 18. So when x goes from 1 to 3, u cannot go from 1 to 3. It will go from 4 to 18. And these are the limits of integration for u. I cannot copy the limits of integration for x because x goes from 1 to 3, but u goes from 4 to 18. And now, notice that for the definite integrals, we don't ever go back to the substitution. There is no need. Because the answer is a number, it doesn't matter if I determine the number using x or using u, but I have to be careful when I transfer the limits of integration. Here, it was a specific, unique example, almost unique, in which the limits were the same. It's not going to happen. So now I'm not going back because this result will be a number. What function prime is 1 over u?
Minus u squared.
Careful, there is only one function that goes with 1 over u. Only one.
ln of u.
ln of the absolute value of u from 4 to 18. You can say skip this because these are positive. I agree, but initially I have to write the absolute value. So this will be natural log of 18 minus natural log of 4. Okay, I think we have time for one more. Let's take a look. Let's look at 61. So the integral from 0 to 1 from 12x, the fifth root of 1 minus x squared dx. Okay. I know what I can say should bother you. Is this quantity in the fifth root? Because we cannot simplify this in any way, shape, or form. So this is what bothers me. So let y be 1 minus x squared. As long as dy, I know that this is a good substitution as long as dy is in the problem. If dy is not in the problem, this is not a good substitution. So, can anyone give us dy, the differential, not the derivative, the differential of y?
Negative 2x dx.
Excellent. Let's see. Do I have dx? Of course I have dx. Do I have x? Of course I have x. Do I have negative 2? Very easy. I can change this into negative 2 times negative 6. Not a big deal. So the negative 6 will go in front because the negative 2 is taken with x is taken and the dx is taken. Do not copy the limits of integration. So we got the dy. This and this and this, and the negative 6 is outside. What does this become?
The fifth root of y.
Excellent. Careful now. When the lower limit of x is 0, what is the lower limit of y?
One.
Excellent. When the upper limit of x is 1, what is the upper limit of y?
0.
Excellent. So then this is negative 6. Y to 1/5 plus 1 over 1/5 plus 1 from 1 to 0. Negative 6 in front. This is 6 over 5, so I have to flip it into 5 over 6. And this is y to 6 over 5 from 1 to 0. Negative 5. When I plug in 0, I get 0. Minus, when I plug in 1, I get 1. And the answer is 5. If you'd like to upload this slide,